and DevOps, you know, I always want to talk about it.
You're the wizard, so.
Well, that's what you said. I'm not at all involved in all that.
It's a nice session title, by the way. Cloud Magic.
Isn't Cloud Magic by itself?
It's catchy.
Well, you know, that's about half of your speaker responsibilities. It's not just about the topic and filling 45 minutes, but it's also about coming up with some interesting title. I'm pretty good in the last part, not that good at everything else that follows from here, but apart from that, I would say to everyone, thank you for being here as well. And maybe some of you remember my Azure DevOps session from, I think, about 3 months back, somewhere October, where my question was to, instead of allocating 45 minutes, if I could get 45 hours. It didn't really work out, but at least it gives me a second opportunity to once more inspire you with some Azure DevOps magic. So what we're going to cover is a full DevOps mindset, where for the ones who are not into DevOps at all, it starts with source files, where DevOps is recommending you to handle it in a more intelligent way, a bit more smarter way, and I'll show you some examples. It means you need to become friends not only with developers if you're coming in from the system side. If you're already a developer and you need to become friends with the system side, that's also fine. But there's also project management involved. And I'll show you a little bit how Azure DevOps can handle that as well. Then the next process is the validation. I describe it as a pre-flight, where you're typically going to validate the source code, testing your ARM templates, integrating your application source code, running a NuGet package integration if it's a .NET app or any other language. There's no real limitation in Azure DevOps what language you can use. And on top of that, it accepts pretty much any target environment. Now, all that is just an introduction to the main topic in the 45 minutes, and that's optimizing deployment. Where again, if you missed the previous session, it's not really built as like a version 2.0 or like a Netflix series where, oh, come back for the next episode. We're not really doing that, but I'm mainly focusing on the optimization of your deployment where you're literally targeting the Azure platform. And then closing with Q&A, where if we don't have enough time within the 45-minute window, I'll be here for the rest of the evening. So maybe keep your questions for later tonight, where we have our drinking sharing opportunity. Now, when you look at DevOps in short, it means you're going to automate your already existing process. So if you're into systems management, you probably have a full collection of PowerShell scripts, maybe some Azure CLI scripts, maybe Azure templates, Terraform templates, or anything that could help you in optimizing your deployment. On the development side, they probably have the same, where you have your application source code, publishing web applications, databases, and anything you could come up with. So the scenario I have in mind is probably something that should be familiar for most of you, at least from a concept perspective, where you could have an Azure template and you want to move this existing template without making too many changes into a DevOps concept, allowing you to create a web virtual machine and SQL database virtual machine. Or maybe because it's not only recognizing virtual machines as a target, it allows you to push out web application source code into an Azure web app. Or maybe you have the same web application source code where now you don't want to use web apps anymore, you don't want to use VMs anymore, because containers are way cooler and you want to move to Azure Container Instance, you want to move to Kubernetes. That would be the scenario. Or maybe ultimately you want to become the lazy admin where you go like, you know what? I like those 3 scenarios and I want to deploy everything at once. End to end, I push the button, I don't need to do anything anymore. Sounds way cool, but every now and then you have managers, they don't always trust what we're doing. So they probably gonna ask like, yeah, well, before you push that button, let's at least have me look at the source code. And before you're gonna deploy it, let me approve it, maybe validate it. Or instead of just pushing to production, where the best dev and test environment is always production, but nobody really understands that. So Your managers might ask for, I want to deploy this scenario to 3 different scenarios if you want, into dev and test, into staging, before it's arriving into production, and how can we optimize this? And then all the way at the end, I'm going to show you how you could even integrate some Azure health state, some conditions, think of Azure policies, and how to make your deployments depending on the actual state of the platform. A little bit about myself for the ones who don't know me. Like you heard, seems like I'm the Azure wizard, still no real idea where it comes from, maybe because I had magic in the title of my deck, but I'm known as an Azure trainer for the last 7-8 years already. Before that, provide a lot of training on the Microsoft data center technologies. Was an Azure MVP before I joined Microsoft 2 years ago. Wow, work is going fast. September 19, decided to stop my own company and move to Microsoft, where I'm mainly providing Azure readiness. And I'm also part of the Azure DevOps V team, where the main benefit is that I get insights in why Azure DevOps is still not dead, because everybody's talking about GitHub Actions, for example. And in the little bit of free time that I have, I'm somehow still going back to Azure, where I'm sharing my experiences, knowledge in a book that's typically coming out twice a year. And just hold on to that. I might have some updates all the way at the end of my session. So with that, welcome to Azure DevOps, where it's, again, end-to-end, allowing you to manage your deployments, any language, any target environment, using all different snippets that I'll walk you through in my demos. The first part is source control. So what is source control? It's your GitHub-alike scenarios, where now instead of moving everything into a public repository in GitHub, we're going to store it in Azure DevOps repos. That's where you have your ARM templates, your developers going to check in code, and everything that's important there. Again, if you missed my previous session and this is like, what the hell is Peter talking about? I would say go back to our website, check that recording, where we spent about 15 minutes just on version control. And I'll reuse a little bit of that in my demos as well. The project management is everything around, typically coming in with development scenarios. You might have heard about Agile, you might have heard about Scrum, you might have heard about swim lanes. So all the cool buzzwords from the development world that now all of a sudden somehow become interesting and important for sysadmins, and I like to call them DevOps engineers now. Where you integrate with Azure Active Directory, you could also integrate with guest users. So there's obviously security in place, but it's not limited to your corporate users. The core item here is work items, where you're going to build the different tasks that anyone should work on. Like Peter needs to publish a web app, Peter needs to create a container, Peter needs to update source code and asking approval, things like that, out of that scenario that I'm going to use. And from there, that's where obviously it becomes interesting. If you run deployments from validation all the way to dev and test, staging, production, you can go back to the work items and, for example, making it smarter, where you cannot approve or run a release, moving something into production state if there's no work item attached to it, because it could mean that somebody's trying to do something that's not part of the official project. From here, we're going to move to the actual pipelines. I promised you some pipeline magic, so that's the core topic. So what is Azure DevOps pipelines? It's not just a buzzword because the whole world is talking about pipelines nowadays, but it's actually your automation engine. Now, for a pretty long time, out of my own example, I was afraid of using pipelines because my assumption was that it was a development tool where if you were not a developer, like coming in from the Microsoft backend, data center backend deployments, I was like, wow, Azure DevOps is not really something for me. So I was still doing everything in a manual way, having a collection of ARM templates, checking them in, moving them into a running state. And in the end, that's what pipelines are doing. So if you have PowerShell scripts already, if you have Azure templates, if you have Azure CLI scripts that you've been using all over the place already, the mindset is move them into Azure Repos. That's becoming your OneDrive in Azure DevOps if you want, maybe your SharePoint location if you like versioning, but we're not using SharePoint for that. And from there, building out your step-by-step tasks. So let me quickly show you what it looks like. I can imagine that you're more into live demos than just watching slides flipping by. So a little bit of my environment, covering some of the topics that I touched on. So I started with creating my project. It's your landing page. That's where everything is happening. And we're going to define certain work items. Like I need to check in my ARM template using the latest schema. Why? Because my ARM templates have been around for about 5 years and not all of them have already been moved into the latest schema. And I also need to build my fast car case demo. That's the application I'm using. It's building a website for a racing company that's interacting Azure Web Apps or virtual machine web VM with the SQL database inside the VM or in web apps or in containers, like I explained at the beginning of the session. This could be obviously a lot more, but for now it's just me. So let's open an item and we're gonna give Peter a little task. So this is doing it and assigning it to anyone within your organization. Just to keep it a bit obvious, I'm gonna link it to myself. I could provide a description what I'm doing here. It's like changing scheme, anything, not that important for now. It's not about work items, it's about pipelines. My repos, that's my starting point, where within each project you can create multiple repos, similar to, again, what GitHub is doing. It's not the only option, it's not 100% the same, but it's actually pretty close. So what I have is 3 different repos linked to the same project, where one of them is loading. There we go. This is my application source code, where I have my web application, I have my W root. That's where I find my .NET app with my app settings and everything that's important to keep my web application up and running. This is typically coming in from the developer side. So they typically going to use Visual Studio, VS Code, or any other development environment, and they push out their application source code. At the same time, I'm coming in as the sysadmin having my ARM templates, where you go like, well, should we store this in the same repository? And technically you can, but why not using a dedicated repo for the purpose of the content? Where you could even take it one step further, defining permissions that your developers can only reach out to the application repo, and the sysadmins can only work with the, in this case, ARM template repo. What I have in there is an Azure deploy template. So everything is in here, my system setup, virtual machines, username, password. Obviously not, because we're going to store that in a key vault, for example. My network layout, the virtual machine layout, like the good old typical ARM template. And again, if you already have them, you don't need to change anything. You just move them into your source control. And from there, you can start sharing them with the rest of the world within your organization or outside. And everybody can make changes, checking in code and everything that you might already know from the GitHub concepts. From here, let's build a pipeline, where a pipeline is typically based on 2 different scenarios. At least that used to be the traditional Azure DevOps scenario, where you're going to run a build stage and from there moving to a release, where the release means we're going to run it in dev and test staging production, and the build pipeline typically is being used for the pre-flight, so the code validation, testing if everything works fine. So one example where I'm going to pick up my application source code, and just to speed up the demos a little bit, I already prepped the pipelines, but in the end, it's nothing harder than combining tasks, where again, most of the tasks is literally what you've been doing for the last couple of years in a manual way. So this example connects to my fast car case source control, where it's picking up the specific ARM items, and I'm going to publish them. Now, what it means to publish, I'm not going to validate anything in my ARM templates. It's just going to prepare them for my build agents. Now, what is a build agent? It's a core component of Azure DevOps where the actual compile operation, or later on, the actual publish operation, is done by pre-built virtual machines. Running Windows for .NET, running Linux for Linux applications, Java, Node, or .NET Core. If you have Mac linked applications, you could also use macOS as the build server. If you don't like using the pre-built Azure DevOps servers, you could also build your own ones running in Azure, running on-prem, where again, the security could be one reason, or maybe you have so many specific configuration customization options where it might not be compatible anymore with the pre-built Azure DevOps servers. That could be a reason. Now, what we're doing from here in this example is grabbing the source code, my ARM templates in the pre-step, and dropping them in an artifacts location. From there, we're going to hand it over to our release pipelines and reusing them. Let me pick up another example that's going to show you a little bit more. Not really. It's hard remembering what each and every pipeline stands for. Let's do something with Docker. We talked about it in this scenario. So what we're doing here is almost the same as the previous one, where I'm going to copy some files. I'm going to drop them on my build agent, where next, and that's where it becomes interesting, I'm going to use my build agent to compile a container. Now, my starting point is still the same source code, the one that I'm using for publishing my application into a virtual machine, the same source code that I'm using in containers, and the same one that I just might use in different dev test staging environments. It's all coming back from the repos, and from there we're gonna push it out. So let me just run one example from here. My agent pool is Azure Pipelines. It means it's okay to use the Azure pre-built servers, and I'm going to use Ubuntu 18.04, depending on the different tasks in the pipeline. It could be required to use a different platform. Then back to source control. I only have one main branch here. If you have multiple developers checking in code, you probably have multiple branches, which means that you could create like a dev branch or a Peter branch where another team member, Tim, is checking in code, but you're not accepting that yet, and so on and so on. Once you kick it off, it's moving to a queue, and that's related to my demo subscription, where I'm not paying for Azure DevOps, and nobody needs to pay for DevOps if it's not used in an enterprise environment. So if you're just using it for like community deployments, if you integrate it with GitHub for public projects, you don't need to pay anything, not even the compute runtime for the build servers. The only downside is that it could take a couple of seconds, worst case a few minutes, before your job is actually kicking off. So in the meantime, it is running. And what it's going to do here is literally, let me zoom in a little bit, is literally running through a step-by-step scenario. So in the backend, it's relying on Git interacting with my source control, running a Git clone from my local, well, not really local, but my Azure DevOps local repositories, and copying everything into this unique build server. By the way, once my pipeline is complete and everything is finished, successful or not, doesn't really matter, the build agent is getting destroyed, which means that if I'm going to run my pipeline after fixing the issue, I'm going to run it again. It's always connecting to a different build server. So in your pipeline scenarios, you need to keep in mind that it's not really storing any state information. So it's copying all my source files, quite a lot of them. So that's why it takes a little bit of time. That's what happens here, storing all the source files after the Git clone into a temporary artifacts folder. Everything from within the source and following, that's literally my source code. From there, it's publishing an artifact. What it's going to do there is creating for example, a web deploy package, or in this case, it's not really doing a lot. But in the last step, where I just defined one task, I want to build and publish a container. It's going to grab my source files, and it's running a Docker compile job. Without doing anything, I don't need to install Docker on my local machine. I don't need to install Docker on the build servers, so they're already pre-built to handle all that for me. So while this is running, let me open up a pipeline. Cool, perfect timing. So let's create a new just to show you that it's quite straightforward to do. So one option is using, oh, let me take one step back. Using the traditional way, it's also known as the classic editor, where easy said it's the look and feel from Microsoft and just clicking around and defining what you need. So the starting point is my Azure Repos. If you have source code in GitHub Enterprise Server, that's the same version but running on-prem, or any other Git compatible scenario, you can use it. Pick up my source code, where from here we're going to use the .NET, that's my language. If you have Java, you're going to use Maven. If it's a Python script, you're going to use Python. It's really that obvious. What it's going to do from here is providing you all the minimal required steps to go from source code into a pre-compiled web deploy package. Again, if you're not a developer, this might be a little bit exotic, but in short, what it does is installing NuGet on the build server. From there, running NuGet restore. It's a little bit of magic out of the .NET world. And again, if it's a different language, it would use something similar like Maven install or npm install for Node. Running .NET build, that's the command line option that you typically would see in Visual Studio. If you press that compile option or the build option out of a Visual Studio menu, that's the same process happening in the backend. You could test it. Let's say we're not going to spend time on testing, but we're not going to remove it because it is actually quite important. And again, publishing artifacts, which means I'm going to compile everything and I'm going to present it for the next step where I'm actually deploying it. Let's see, save and queue. And this is live demo 1 or anything else. It's .NET, so I can use Visual Studio. Let's try Windows 19. Why not? I'm not sure if my previous pipeline is done, but if so, then this next one will kick off. That's mainly what's happening here. So I showed you classic pipelines could be a lot more complex than that. Now, classic pipelines have some downsides. The good thing is obviously that even if this is like the first time you're seeing it, it's literally going through a sequence of tasks. And if you have no real idea what you're doing or how to achieve it, you can open up the task list and just searching and selecting what you need. So if I want to, a little bit too late, but let me go back to my pipeline. And let's say I'm gonna run my NuGet compile, but at the same time, I also want to turn this into a Docker container. I already have a pipeline to do that, but nothing stops me from actually doing the same thing again. Where now I'm integrating a Docker task, and I can define some settings like interact with Azure Container Registry. My repository is gonna be called MC2MC. What is the task within Docker I want to execute? So build and push means I'm going to run Docker build. If you're familiar with Docker, it's literally executing the command line options and from there also pushing it out into the container registry. If you just want to build it, you don't need the registry. Maybe you just want to go through starting up a container, validating something and stopping it. So anything again that you run as a pre-flight validation, like is my application actually working fine? That's what you're going to do here. I'm not going to save it. And good. Another scenario, because I talked about classic, another scenario is using the newer approach, and it's described as YAML pipelines. So what is YAML? It's moving to a concept called pipelines as code, where a lot of the core concepts are still the same. It's a sequence of tasks, but instead of storing them in somehow Azure DevOps native proprietary format, it's going to move them into YAML code, where the advantage of YAML is that it's an open standard. If you have other DevOps scenarios like using Jenkins, using GitLab, using Octopus Deploy, in meantime, they all support YAML, which means that you could start from here, and from there you could move it into other YAML compatible scenarios. Another advantage is that your pipeline is now becoming part of your Azure Repos, where the documentation is a lot easier. Sharing the pipeline is a lot easier. If I need to build up my testing pipeline that is now running in the backend, it's 5-6 different steps where I need to take screenshots providing additional documentation, where now it's just one flat text file. The downside of YAML is that it's still pretty new, although it's been around for about 10 years, but not everybody's super familiar with YAML already. The syntax is a little bit weird every now and then, a little bit similar to ARM templates. If there's a comma missing, if there's a space too many, then it's not recognizing anymore what it needs to recognize. And then obviously your pipeline is not going to run. If you want to migrate from classic to YAML, you could also do that. So that's an easy way to learn a little bit to deploying anything in Azure using the portal, exporting to an ARM template, and taking it from there. So we provide you that migration window. So we're now in the scenario where our pipelines are done. We validated everything, we tested everything, and this means we're ready for deployment. What is deployment? It's again pipelines, the exact same scenario where you're going to build a step-by-step sequence of tasks, but typically this time you're going to target a platform. To push it out from your DevOps environment into the target platform, which could be Azure, could be VMware, could be a virtual machine on-prem or in Azure, AWS, doesn't matter. It's based on a service connection, where the service connection, no surprises there, is running using service principal in Azure, a service account object in AWS. That would be the idea. So keep in mind that every now and then, depending on how you organize your application source code or templates, that typically the deployment is not running in your admin user account, but it's running in a service principal environment, which means that you need to integrate RBAC, you need to define what are the permissions, and everything that you might already know from RBAC is still in place for that service principal as well. The other thing is back to our scenarios where we have the Docker container, it's compiled in meantime. We have the web app source code pushing out the web deploy package, and we have that ARM template allowing us to pre-build virtual machines. And in the next step, that's where we're gonna use it as a target. Integrating dev test Q&A production. If for the ones who are using Windows Insider, you're familiar with the terminology probably, but in nowadays technology or software release cycle, it's not always about dev and test Q&A production anymore, but you typically see like canary builds, early adopter, and from there moving to a production state, or even a LTS longer term strategy version. So it's technically doing the same, where the canary build is close to dev and test in the old way. Q&A is close to the early adopters, where it's not 100% production ready, but getting pretty close. And the LTS version is what we would have called production in the old terminology. Let's move on. A little time check, way cool. So I already again prepped just to speed up the demo a little bit. So let's start with a first example where I'm going to run a web app deployment. So what I'm doing there is creating new pipeline. It starts with a stage. So let's give this some descriptive name. test, a bit more sense in stage 1. We start from the pre-built artifact out of the build stage. And from here, we're gonna run it in, or moving it into a running state. Now, what is a running state? It means I have my web app source code, and I'm gonna push it into an Azure app service. It needs my Azure subscription. That's done out of my service connection. I'm gonna run this on web app on Windows, and it's picking up some weird app service name syntax. Now, where does this come from? It's or allowing me, it's just to be sure. But from here, since I already have my subscription up and running, I have some web apps already available. And if I know my backend environment, because maybe my Azure cloud team already pre-populated an empty web app instance, that's what typically happens outside of DevOps before, where the cloud team is creating the Azure resources, AWS resources, anything else you want to use as a target. And the developers are bringing in code, what we just did, compiling, testing, and we're now ready to push it out. Also described as right-click publish in Visual Studio. But what happens if we don't have that environment yet, or we want to make it a little bit more intuitive? What we can do is integrating variables in build pipelines as well as in release pipelines, where we're going to define static variables. That's what I'm doing here. I create an alias where my deployment is known as PDT with some unique number. Or what if I'm using the same variables in build pipeline, in release pipeline, but not just one of them or two, but all pipelines within this project? Then it might be better to move to a variable group. And what I'm doing there is literally defining all the possible variables that I need. I talked about containers, which means at some point in time, I'm going to run a deployment that's creating an Azure container instance, Azure container registry with some user information for the registry, my app service name, and so on and so on. Now I can use static information, like my automation account is called FastCar, my location is called West Europe, so that's static. My SQL database name is not really going to change because that's probably stored in my app settings JSON file or a web config file if you're not using Key Vault. But what you can do is interacting with variables similar to what you do in PowerShell CLI, but this time storing them in Azure DevOps. So what I'm creating here is a name for, let's say, my web app. That's what I'm going to publish. It's called variable ATT alias FastCar web app, where the ATT alias is that static alias up here. So I can perfectly combine the two together. So publishing it out, this is connecting to my Azure environment, where if all goes fine, I should already have everything in place. If my cloud admin did a good job, let's see how far Azure goes. Apparently not that far. Oh, there we go. So I can see that my Azure resources, come on, are in place. My something FastCar web app, perfectly fine. And the starting point is that web deploy package, actually my technical artifact as the starting point or the end point out of my build process. Now, if I'm going to push this out, it's only partly going to work. So the web front end will be there, but it won't be able to connect to my SQL database. Why not? Because we're literally picking up the existing source code that we have, which means that we have a hard-coded web config file setting. So what we can do is run a little Azure CLI statement. And again, this is nothing new to Azure DevOps, but what I'm doing here is literally running a little Azure CLI AZ web app config, where I'm going to update my connection string and reusing information from my Azure DevOps variables. Why is this possible? Because again, the pipeline picks up the variables once it kicks off, and from there it's going to recognize all the settings, parameters, and just literally updating it. It's not literally rewriting the web config file, because what I'm doing here is using the Azure Web App application settings. So the web config file will remain the old one, but if you know a bit about Azure Web Apps and the app settings, it means that they always get priority. I'm not going to push it out yet because I want to show you something else where I could use ACI as another example, making it a little bit more complete, where now I'm starting from a different artifact. This is the container artifact that I built in my build pipeline. Deploying to ACI, and the only thing I'm doing there is running again some CLI statements. Why? Because there's no pre-built task to publish an Azure container instance. But if you already know Azure, this could be Azure PowerShell. This is Azure CLI, but technically would be the same. And this is most probably like 2 lines of code that I already used in my non-DevOps way of working. So if you already have the process in place, you have all the scripts, the CLI statements, it's literally copy paste, move them into Azure DevOps and done. If you remember my scenario, I also talked about virtual machines. So why not connecting to Azure DevOps repos, picking up that ARM template, and from there running different jobs. So what I'm doing here is creating an Azure resource group. Get a little bit bigger again. Creating an Azure resource group, creating a storage account. Why? And that's just something you need to know. That's why I'm talking about it, obviously. If you move everything from your Azure repos into the build server, and from there you're going to copy it into your Azure target environment, it's not always going to work. Why not? Deploying a traditional, straightforward Azure template is fine, but in my Azure template, my ARM template file, I'm using nested templates, and I'm also using desired state configuration, where out of the ARM templates, I'm deploying Azure storage, I'm deploying the virtual machines, but once the VMs are live, I'm going to kick in desired state configuration to install the web VM as a web server and the SQL VM using PowerShell, SQL PowerShell to install the SQL server, run the configuration and everything. So to make that happen on the Azure backend, I first need to copy the files into a temporary deployment storage account. So that's what I'm doing here. In step 1, create that in between temporary storage. It's all using Azure CLI again, just as an example. Once I have my storage available, I can run a new task where this could be command line as well, but just showing you how the different options are nicely working together, where I'm going to use my ARM template location as a starting point, dropping the files in Azure Blob, and I'm using my variable ARM storage account as the name of my storage location and the hard-coded name container, because this is probably not really changing. From there, I need a storage account token, where Azure CLI is a little bit harder to pick up storage account token. So I'm switching back to another 2-line script that I already used like 5 years ago to read out the storage account context and picking up the storage account token. And that's what I'm going to reuse and running an ARM template deployment. So 4 basic steps that's allowing me to grab my ARM template, copy all the ARM template files, the main template, link templates, DSC, other PowerShell scripts if you want to run virtual machine extensions outside of DSC, that would also be an option. And from there, handing them over and running my deployment, where all the variables I talked about are 100% coming back. Now this is all running in my main stage. I already deployed it, everything is there. So let's move on to the next scenario where we're going to make it a little bit more intuitive, maybe a little bit smarter. So what you can do is creating different stages. I'll show you that in another demo. Now, once we have our different stages, think back about our managers coming in, like, I don't trust Peter's code. I need to validate what's happening before it's actually running on Azure. So we can integrate manual approvals, or we could also integrate with a health state or a validation state out of my Azure environment. So in my example, I'm using West Europe as a target. It's hard-coded in my variables, but maybe I have an Azure policy in place that doesn't allow me to deploy something in West Europe. Or why would you deploy your Azure pipelines, pushing out to new Azure storage, pushing out to Azure Web Apps if, for example, out of Azure Monitor, you're going to find out that the web app is not running, that the region is not available, or anything else. Or back to Azure Repos, where I started, querying work items, where you could come up with a scenario that if you know that my end-to-end pipeline deployment task is taking 10 different steps, which probably means I'm going to allocate 10 different work items to Peter. And if I have more than 4 outstanding, which means I didn't really do a complete job, we're going to force Peter to first fix the work items before we're going to allow the deployment. So that's a couple of nice integrations known as quality gates in the official documentation. And I'll show you what it looks like. So from here, let's create a new stage where, just to make it easy, we're just going to start from what we have. And this is, let's say, production, where this would be early adopter or anything else, not that important. Everything is there, where maybe the only thing I'm going to change is the target location. I'm not even going to change anything just for the sake of the demo. But what I can do is integrate pre and post deployment conditions. So from here, I can integrate approvals, where I'm going to link this to myself just to speed it up a little bit, where I need to make sure that I'm not flagging that the one who's pushing out the deployment can actually not approve it. That's obviously some kind of safety net. And just to see how far we can get, let's do, Tim, what is your email address? Gmail, is that fine? Outlook? Looks Gmail like my directory already knows you. Which one, Gmail?
Yeah, it's okay.
Yeah, I told you Azure DevOps is all accepting all platforms, so it probably will be able to send you an email as well. And let's see how far it goes. That's good for now. So what it's gonna do, make sure I'm gonna save it, is when I'm running this deployment, it's gonna deploy the early adopt environment. And before moving to the next step, like publishing to production, it needs an approval from myself, and in this case from Tim. If you allocate like an Active Directory group or Azure Active Directory group, you can define like how many need to actually approve it. Typically 1 would be fine, but if you need more, you can define it. The other option is the gates integration here, where you can define a couple of different options. There's plugins in the Azure DevOps Marketplace to actually make this even smarter than it already is. So let's do something with work items, where I'm going to define nothing. Why not? Let's start with this one and then see why it's not recognizing it. I probably forgot to save, disable, and didn't change anything. Cool. And then while this is kicking off, I can check why it's not picking up. So this is queued. Let's wait until it kicks off. Come on, 5 more minutes. And it's running. Cool. Quickly checking my work items. If it's not there, it's probably because I didn't prep it. properly enough. So those are my items. It's because I don't have a query. That's why. This is Peter's work. So it means that if there's a work item outstanding, we don't allow you to run the deployment. So that should be good enough. So while my release is running, it's still in early adopter. I can already make some changes. Where we're going to move to a pre-validation where the work item, let's see if it's, there we go, nice. So whenever the threshold is more than 0, which means if there's at least something showing up, we're not going to allow the deployment. Or let's do something with Azure policy, where it's going to validate my subscription for my target resource group and optionally my resource if I want to use it. I could define policy compliance. So Azure DevOps by itself is not really aware about Azure policy, but obviously the assumption here is that I already have an Azure policy in place that's assigned to my resource group or subscription. And whenever it detects a policy validation similar to the manual Azure deployments, it's gonna fail my production deployment. And let's run a new release and check back what happened with the previous one. Come on, 2 more minutes. It's still running. So it did the artifact step. It created the Azure resources out of CLI, copying the files, running that token, and now it's running my RM template. Tells me validation is fine, so I'm just gonna give it a little bit more time and then checking back. Or let's cancel this one. And then hopefully I can still show you the outcome of the Gates integration. It's always fun to mess around a little bit. So I got my gates over here. So let's move that approval. And we did Jim as well. So I don't need to approve it. And then now I can get rid of my early adopter and it would still be okay. There we go. Just to speed up the demo, obviously, don't push anything into production if you didn't test it, but in demos, it's working perfectly fine. Then it's probably going to take a couple of minutes. It's also the downside of the release gates that it's only validating every 5 minutes. So I won't be able to show you live, but I hope the outcome, or at least the intent of the additional optimization options are clear. Again, the downside is that it's the lowest parameter you can set is 5 minutes. So if it fails, it's going to wait 5 minutes, validating the policy again, validating the work items again. That's the main idea. So with that, we're close to the end, where I started a little bit with source control, a little bit on the work items with a lot more that I didn't talk about. The pre-flight validation, also known as the build stages, the deployment optimization, integrating ARM templates with Azure CLI, Azure PowerShell, application source code. This was Azure oriented, but could be other target environments as well. I told you to move Q&A to the end later tonight. But one last thing I want to share. If you enjoyed the session, or even if you didn't enjoy it, but don't tell anyone, and you want to learn a little bit more about DevOps, I recently published a book, happened right before Christmas, only a couple of weeks back, so totally super up to date. So just to generate a little buzz around Azure DevOps, convincing the team that it's not all about GitHub Actions, feel free to send a tweet having my handle PDTIT, Azure DevOps, and obviously community MC2MC in there. And later tonight, before we're closing down, I'm going to check back. Anyone who's tweeting using those 3 keywords might win a free book. And if I'm not wasted yet, I might actually share a book with each and one of you who's using those tweet messages. With that, I'm going to close down. Thank you for being here. As usual, 45 minutes is way too short for anything that I want to share, but nevertheless, I hope you enjoyed it. And over to Wim. Thank you so much and see you later tonight.
So thank you.